Welcome to my presentation. In this presentation, let us see how we can solve linear equations of the form ax plus b equals to c using the addition, subtraction, multiplication, division rules. So let's say we have an example of this type. Let's say the example is we want to solve 11 over 27 is equal to 4 over 9 minus 2z over 3. So in here we want to find the value of z, and we're going to use these different properties to arrive at that. We want to isolate the z term to one side of the equation and find the value of z. So to do that, we're going to follow these different steps. Step number 1. Since we have 4 over 9 on the left hand side of the equation, we're going to subtract 4 over 9 on both sides. First, we can either say subtract 4 over 9 on both sides, or we're going to add negative 4 over 9 on both sides of the equation. Both the ways of saying it is correct. Add 4 over 9 on both sides of the equation. So how do we write that? Negative 4 over 9, that is what we are adding, plus 11 over 27 is equal to negative 4 over 9, that is what we've added on both sides now, plus 4 over 9, which is existing on the right hand side, minus 2z over 3. Right? So now, since on the right hand side we have negative 4 over 9 and positive 4 over 9, those cancel out, leaving us with negative 2z over 3 is equal to, we need to simplify negative 4 over 9 plus 11 over 27. So let's take that onto the side here. We have negative 4 over 9 plus 11 over 27. We want a common denominator of 27. We know that 27 can be written out as 9 times 3. So if we look at the first ratio and multiply and divide by 3, we will have the denominator for the first fraction as 27. So therefore, we're going to multiply and divide the first fraction by 3, and that will give us a common denominator of 27. So when we simplify this, negative 4 times 3 is 12, divided by 9 times 3 is 27, plus 11 over 27. So as long as we have a common denominator, we can write that once, then combine the numerator parts. So therefore, negative 12 plus 11, that's going to be equal to negative 1 over 27. So that is how we can simplify that fraction on the left hand side. Then therefore we can come back here and write this one as 1 over 27. We want to find the value of 1z, not a fraction of z. So therefore we'll write that as step number 2. And now we are going to use the multiplication property and then be able to get rid of the negative 2/3, which is attached to z as its coefficient. So we know that when we have a number and when we multiply that number by its reciprocal, the product is always going to be equal to 1. Since we have negative 2/3, and if we wait to multiply that number by its reciprocal, which is going to be negative 3 over 2, the product is always going to be equal to 1. Negative times negative is a positive. 2 in the numerator, 2 in the denominator cancels out. 3 and in the denominator, 3 in the numerator cancel out, leaving us with 1. So therefore we're going to say multiply by the reciprocal, which is negative 3 over 2 on both sides of the equation. And when we do that, this is what we're going to come up with. Negative 1 over 27 is what we have on the left hand side. We're going to multiply that by negative 3 over 2, and that is going to be equal to negative 2. Let me distinguish that between a 2 and a z. Negative 2 over 3z, and then we are multiplying that by negative 3 over 2. As you can see, the negative on the right hand side, the 2's cancel out, the 3's cancel out, the negative times negative is a positive, so we are left with a positive z on the right hand side is equal to negative times negative is a positive, and then 27 is a multiples of 3. 3 times 1 is 3, 3 times 9 is 27, and therefore we have positive 1 over 9 times 2 is what is left in the denominator, so therefore that is our answer. Z is equal to 1 over 18. That is our answer. We want to make sure we have arrived at the correct answer. To do that, we're going to check our work, and we'll do that in this step number 3. In step number 3, we'll do that in this step number 3. And how do we write that? We substitute this back into the given expression, and we want to see whether we get the value of value on the left hand side equaling the value on the right hand side. So we have 11 over 27 is equal to 4 over 9 minus 2z over 3, and we are now going to substitute the value of z. So 11 over 27 is what we have on the left hand side is equal to 4 over 9 minus 2 over 3, and for z we are going to substitute the value 1 over 18. That is what we got as a solution just a few minutes ago. Okay, now we can simplify this expression some more. So let's write this. 11 over 27 is equal to 4 over 9 minus, we're going to simplify this. 18 is a multiples of 2. 2 times 1 is 2. 2 times 9 is 18. So therefore we can write this as 1 times 1 is 1, 9 times 3 is 27. So we want to simplify the right hand side, where we have 4 over 9 minus 1 over 27. We want a common denominator of 27, so therefore we go to take the first fraction and multiply and divide by 3, and when we do that, it's going to simplify as follows. 4 times 3 in the numerator is 12, 9 times 3 in the denominator is 27, minus 1 over 27. The common denominator is 27. When we combine the numerator parts, it's going to be 12 minus 1, which is going to be equal to 11 over 27. And this right hand side's simplified to 11 over 27, and that is exactly what we have on the left hand side, 11 over 27, and therefore this goes to prove that the value of z, what we have obtained as 1 over 18, is exactly correct. So this is the way we want to solve linear equations using the addition, subtraction, multiplication and division properties to do this. In my next presentation, we shall look at some more examples to see how we can solve linear equations of the form ax plus b equals to c.